Here at the museum at Texas Tech University, the paleontology division has been working very hard over the course of the past year to bring our use of technology up to date. There's a lot of really amazing equipment and software which is available to us now in paleontology that would have been completely unimaginable to me as a graduate student back in the early 2000s. And it's been pretty exciting to actually learn how to use a lot of this equipment and software. And what I want to talk about today specifically is some of the new tools we have for making replicas of fossil specimens, and to show you the speed and ease with which we can actually use this technology. For most of the history of paleontology, if you wanted a replica of a fossil specimen, you had to rely on molding and casting, which means taking your fossil specimen, surrounding it with a two-sided mold made out of latex or some kind of synthetic rubber to create a negative of the original fossil, and then filling that negative with plaster or liquid resin, which then hardened to form a copy of the original fossil. And this was usually in turn surrounded by some kind of plaster mother mold to help the replica keep its shape while it was in the process of hardening. The advantage of molding and casting is that you end up with a pretty high fidelity replica of the original fossil, but there's several disadvantages. One is that the molding process itself takes hours and hours of work. Molds themselves also tend to wear out over time. The rubber will start to wear and tear. However, in recent years, it's become a lot faster and easier to create 3D models, virtual models of fossils inside the computer, and then to print these out using 3D printers. While fossil replicas produced this way usually don't quite have the degree of high surface detail that you see using traditional molding and casting, this process can be extremely fast and very easy to use, and of course is also far less destructive to the fossils themselves. There's two main methods that are used for creating 3D models of fossils. The first relies on using a scanner that uses laser or infrared or some other kind of light technology. These can create some pretty high fidelity models of fossils. They're pretty accurate, but the big disadvantage is that they're oftentimes also very expensive. The Arctex Spider scanners, which are that's one of the more popular brands, those can run you several tens of thousands of dollars, and the software itself is usually also not cheap. But there are some smaller and less expensive models available out there that are also very convenient if you're traveling to collections and want to take a scanner with you, like the one you see Dr. Weinbaum using here. The other popular method for creating 3D models relies on what's called photogrammetry. So with photogrammetry, you take dozens and dozens of photographs of fossils from different angles. Then you run these photographs through software that identifies landmarks that are shared between different photographs taken from different angles and uses these landmarks to reconstruct the shape of the original object. Today I'm going to show you what you can do with a photogrammetry app called Abound, which used to be known as Metascan. And this is an incredibly convenient and efficient method for creating 3D models that I've really fallen in love with. So what I have here is a fossil that I have decided that I want a 3D replica of. I have the specimen here, which consists of two osteoderms, or two armor plates, off the back of an armored reptile called Desmatosukis. We start by basically opening the software. You hit the Abound button, the software opens, and then I'm going to hit plus, which is going to allow me to do a new photogrammetry scan. And the best setup for this is to have a turntable like this. These are fairly expensive. You can order them off Amazon. I'm shooting it from a little bit of an angle, and I do about 15 like that. I move it down a bit further, do another 15. So I've now got about 45 photos, and I'm shooting it more or less straight from the side. What I've done now is to turn the object on its side. You kind of want to rotate the object into at least 2 or 3 different angles, especially if you got a really flat object like this. And now I'm just going to repeat that process. I've now got about 100 photos. I'm going to shoot it from the bottom now. So again, I start the turntable. By the time you're finished, you want to do maybe anywhere from 100 is kind of on the low side, but anywhere between 100 and about 200 photographs. I usually take about 150, 160, something like that. And what I will do now is just to hit done. It will take me to this screen, and then I will hit process, and it will begin the process of uploading all those photographs to the server, which again you pay a subscription service to use. This will probably take some time. It's important to leave it on this screen while it is doing this. If you close the screen while it's still in the process of uploading, you'll have to start it over again. But eventually it will complete the upload, and then you'll get a message saying that it is the process of processing it. At that point, you can close the screen, and when you're done, it'll send you the 3D model. So now the server has sent my 3D model back to me. So I just basically touch that. There's the 3D model, and I can just kind of check it over. I'm looking at it, checking all the sides. If it wasn't processed properly, you might get a 3D model that only has one side to it, or where one of the sides is kind of like crude, is like kind of a crude mass of polygons. But this one actually looks pretty good from all angles. If we kind of zoom in a little bit, you can see the detail holds up pretty nicely even when you get fairly close to it. You hit share, and then and I want to send it to myself as two different file formats. I'm going to send it to myself as a USDZ file, which is a nice color 3D version of the model, and then I will also send it to myself as an STL file, which is sometimes a little bit better for printing. And then I will choose Outlook, because I'm going to mail it to myself using my email account, send it to myself as an attachment. So now I've got my 3D model, and I'm going to get the STL file ready for 3D printing. I've got an Anycubic printer, so I've been using the Anycubic Photon Workshop. With this particular model, what I want is kind of like just a kind of half-size model that's convenient to kind of take with me, sort of like a toy version of the original. So what I do is I just kind of get it positioned on the plate here, and I'm just going to shrink it down. So I'm going to go to scale, make it about 50% the size of the original specimen, and there it is. I'm going to position it a little bit better. I'm going to rotate it so I don't have to have as many supports on the bottom. So I'm going to kind of stand it on edge, kind of like this. Go to supports, automatic generate supports, to see how that looks. Go to slice plate. All right, and save to disk. So then I plug in my USB. There it is, just drag it on the USB drive. This is the resin printer I've been using, the Anycubic Photon Mono M7 Pro, which has been working out great. So basically all you do is you plug the USB into that, you choose the USB, select your model, which should be that one, and then you literally just hit print. And the estimated print time is a little under 2 hours. So after about 2 hours, the build is completed. Let's see how it looks. There it is, hanging from the bottom of the build plate. Looks pretty good. Yeah, came out pretty nice. So now I popped it off the build plate. Now we're going to throw it in the wash and cure station, which is another Anycubic product. We'll wash it first to get the excess resin off the surface, and then we'll pop loose the little supports, and then we will cure it. Resin printing works by basically using UV light to cook the resin into a solid, and so we basically need to finish that process. This is the wash and cure station, which is getting pretty dirty. As you can see, I'll probably need to swap out the isopropyl at some point. Here's the specimen sitting in a basket. Dump it in there, put the lid on, and turn on the wash and cure station. 3 minutes is on to do it, and then it just has a little rotating fan at the bottom that stirs up the isopropyl. There it is, all washed off. Just popped off the little supports. That's actually the easiest support removal I've ever seen. It took about 3 seconds. Cool thing about this Anycubic station is it also functions as a cure station, not just a wash station. So I've taken the isopropyl vat off, put this little stage on it, then I throw the top on like this, change it to cure. We'll do about 5 minutes on a side, hit start, and a little UV light comes on, and the stage rotates, and it cures So while that's cooking, let me show you some other cool models that I've been making. This is just an example of another reduced size 3D model. So this is a Phytosaur skull that I did photogrammetry of at Petrified Forest National Park. Again, just like I just showed you, just basically put the full size skull, which is about this big, on a turntable, did photogrammetry for it, and then basically just sliced a 3D model at about, I think this is about 1/4 size. Complete articulated Adasaur pelvis. This is also about, I think, 1/4 size. Here's a bunch of osteoderms and bones from another Adasaur specimens, these printed out at full size. Also created using photogrammetry. Ta-da! All done. And here's the full size osteoderm with my printed miniature version.